it was the hell of a tailwind.
Yeah, Rob.
I ran downstairs to grab a book when you guys were talking earlier about the Fauxcalt pendulum, because I just read something last night, and a book's called 50 Reasons Copernicus Threw the Bible by F.E. Pash, copyright 1915. And regarding the Fauxcalt pendulum, he talks about this guy, Dr. Schopfer, I think is how you pronounce it. Anyway, he was an eyewitness to the original experiment by Fauxcalt, and he says, quote, in an introductory speech by Dr. Menzer at Coldenberg or something like that, showed that until then there had been no proof for the Copernican hypothesis, the so-called proofs being, after close investigation, just as many computations, until the Fauxcalt pendulum showed the rotation of the Earth uncontrovertibly. The pendulum was tied, the string was burnt, the swingings began, but the pendulum deviated to the left instead of to the right. It was hastily brought to rest. New burning of the string. This time the deviation was the one desired, and we were invited again to present in the church the next morning at 8 o'clock to be convinced that the deviation agrees with the theory. On the following morning, however, we saw that the pendulum during the night had changed its mind and had, from the deviation to the right, again returned to the left. To me, this seemed new proof that did not seem to be quite in order. My belief in the Copernican doctrine was shaken by the speech of Dr. Menzer, and I concluded to go to Berlin for an explanation. After seeing the pendulum experiment here also, and strangely again with the deviation to the left instead of the right, I went to Alexander V. Humboldt, who was indeed over the first refuge of those seeking information. He received me very friendly and spoke the memorable words, quote, I have known, too, for a long time that as yet we have no proof for the Copernican system, but I shall never dare to be the first to attack it. Don't rush into the wasp's nest. You will but bring upon yourself the scorn of the thoughtless multitude. And it goes on to talk about every time they initially tried it, it wasn't giving the results that they were wanting. In fact, it was often going the opposite way that it should be going. So they would stop it, try it again, we got something wrong, and then would set it in motion, and then overnight it would revert to going the wrong way.
So
that's classic.
So, Rob, I'm actually looking at while you were saying that, a 3B Scientific Physics. It's a $6,500 Fauxcalt pendulum you can purchase from Amazon. It's in a big glass case. And as I'm reading it, it's basically telling you how to do these experiments in front of students, and it says exactly what you said, that set up the Fauxcalt's pendulum on a horizontal surface, using your hands, check the housing for vibrations, and then it says that you want to let it go, and if it doesn't go the right way, then the test needs to be stopped and restarted. It says when the swing.
Notice how they don't say, go ahead and push it a little bit to the right. They say, if you don't get the results, you won't keep doing it. But essentially, they could just go ahead and say push, give it a little bit of a English to the right. Right.
Yeah, it says here, an electromagnet with a radially symmetric magnetic field is mounted exactly in the middle of the pendulum's path. The magnet only has an effect when the pendulum is moving towards the center. The electromagnet is controlled by a photovoltaic cell, which registers the shadow of the pendulum motion by the light provided by a built-in fluorescent lamp. The pendulum is excited in a way such that its amplitude remains constant. It's just funny. I mean, all these have to be included in it.
Yeah, I went to the Griffith Observatory where they have that pretty famous one there, and I'm in line with the tour, and the tour guide in the middle of the presentation says, yeah, to keep this thing going and everything, there's an electromagnetic motor up there on this special gimbal swivel deal, and she just kept going like, okay, we're telling you this thing is being moved electromagnetically with a motor up there, and it just kept going. And so they had this little model over on the side of a globe with a little teepee on it and a little hanging pendulum. So I went over to the model, and another tour guide came over and saw me looking at it, and they said, so do you have any questions? I'm like, yeah, can you explain it to me again? I heard what the other tour guide said, and he went into even more detail, and again pointed up and said, yeah, there's a motor up, otherwise the thing stops, and there's all, I'm like,
well, this one here
doesn't that defeat the whole purpose of what this is supposed to be doing?
Totally. It says here, if the experiment is conducted with excitation, then the amplitude must be observed for approximately 5 minutes, and if required, should be corrected using the excitation adjustment switch. So then there's a switch that can displace the pendulum bob by hand and release it. During the experiment, the pendulum must swing in one and the same plane. If it begins to swing in an elliptical path, the experiment must be stopped and restarted.
Yeah.
Don't you love that overly
I do not think that
complex
word means what they
euphemism?
think it means.
Yeah.
And that's is a curious thing because the elliptical path is the path of the sun.
Oh man, these guys.
Well, yeah, but to Bob's point, I think it would make sense if they would try to eventually figure out these zones, if you will, where it would give you the results that you want more consistently. And in the beginning, they were just thinking in principle, hey, let's try this out, but it's going left, it's going right, it's going, until they probably through trial and error maybe have figured that out.
Yeah, in the early 18th, the mathematicians Mach, he pointed out that you can have the same effect if you have a rotational firmament, the drag of the ether.
Right.
So,
the ether. Right.
Exactly. He disproved.
Yeah.
In those days, I think that is why they the same guy who invented the pendulum is the same guy who needs to invent the gyroscope, because I think that at that time the scientist community, they just say, okay, this pendulum, man, you need to push it for yourself. It's stopped. They can go in any direction. So we need to invent something else because this is not proof nothing. So the same guy in that period of time was the most, the most list of experiment to trying to detect the motion of the Earth. The pendulum, the gyroscope, the Sagnac experiment, the Michelson-Morley, the Michelson-Gale, and all failed. Or I mean, all give us that the Earth is motionless.
Honestly, I don't even see, like, if you get perfect results on one of these pendulums, I don't see how the results lend themselves to a spherical spinning Earth unless you were standing right on the North Pole. To me, if you were standing at somewhere near the equator or tropical or whatever, I just honestly don't see how spinning around the axis, as they say, would translate to that pendulum going around in a circle. Like, I honestly, I don't see it.
I agree, John. I so agree.
It's completely
It's
different.
never made any sense to me.
They claim
It's smoke and mirrors.
It's the latitude that you're at. So if you're at 35 degrees north latitude, you'll have a different period of motion than if you are at a, let's say, 55 degrees north. It'll be a different period. And so they say that they can calculate within 2 degrees the latitude just by the entire period of not gyroscopic precession, but the precession of the Fauxcalt pendulum. Now that's a claim that they make. I haven't seen it made.
Well, to me, what jumps right out, and just like it always does, is the fact that they claim that this behavior of the gyroscope is exclusive to a globe, and of course, I don't think that's exclusive to a globe at all. Did I cut out?
Right.
No, I thought we lost UAP. I'm sorry. Go ahead, UAP.
Oh, I was going to say that if it is something that would bear out, which again, I reject the premise because it's not a repeatable and reproducible experiment, not to any kind of statistical standard that is accepted otherwise. But okay, let's accept whatever it is here, the significance of it. You could explain it in other ways. They only want to consider their one hypothesis. So it could be proximity to the sun or a number of different things like that, like you mentioned, that could explain a varying rate based on your latitude of the experiment. And I use the term loosely of experiment because, like you said earlier.
Well, I mean, if you assume, let's just go the other way for a minute and assume, for argument's sake, that there is a magnetic vortex that's centered on the North Pole on a flat Earth, then the vortex itself of that field would be going at a faster rate through space